Now right here I'm putting up some classwork here, or video notes here on 1-2 CW1 manipulating formulas. The reason why is because I know manipulating formulas can be very challenging at times, especially when you're first learning it. But more and more you practice, the more better and better you'll get. So, looking at this worksheet, I put this up online so we could talk about it a little bit more and you could submit your answers to make sure you review what we've talked about a little bit during class. Now, on the top here we talked about donuts and circles. We know that the area of a circle, the inside of a circle, the formula for it is area equals pi r squared. Now, we have two circles. A donut is one big circle and then a little circle. To find the area of a donut, we do the area of the big circle minus the area of the small circle. And that will get us the area of this donut. That will equal area of donut. We're going to apply this concept over the next couple of problems here in 1-2 CW1. So we can find the volume or the areas of the particular figures that we're looking for. So first one we're going to talk about is problem number 1. Alright, in problem number 1 we have a nice little cylinder here, which is pretty much a 3D donut here, where you can have a radius of the small circle on the inside and a radius of the big circle of the big side, and you're given the height in both of them. So, in our figure here, we have those two donuts. Sorry that my picture's not perfect. But this is our cylinder here. Our goal is to find the area of the cylinder. So first we got to find the area, or the volume, the volume of the big cylinder. And then subtract the volume of the little cylinder, and that will get us the area of the cylinder that we're looking for. So the volume for any cylinder is pi times radius squared times the height. So the volume of the big cylinder, BIG, will represent the big cylinder, will be pi times our radius of the big cylinder is 10 millimeters. So we have 10 squared, and the height is 12. Now we could simplify that down. So the big cylinder is really pi times 100 times 12, and 12 times 100 gets us 1,200. So it's 1,200 pi, because that's what times pi is. That's the volume of the big cylinder. Now the little cylinder, the volume of the little one, or the smaller one, let's call it little, is pi times radius squared times, well, the height is given for us for the little guy too, which is 12. So if we rewrite it, make it nice and pretty, we have 12 pi times r squared. That's the volume of the little. Now just like what we talked about, to find the volume of this particular cylinder, I do big minus little. So the volume of the cylinder that we want to find is big minus the little. So when we write that out, the volume of the cylinder we want to find equals 1,200 pi minus 12 pi r squared. Now we got to factor, because that means a lot of people find factoring to be a lot prettier, so we got to factor. 1,212, what you could take out there is a 12. These terms have a pi in it, so you pull out a pi. But neither one of them, not both of them, has an r squared on it, so we have to leave the r squared in there. So, in parentheses, 1,200 divided by 12 is 100. We took out the pi. Minus, well, we factor out 12 pi in this term, so all that's left is r squared. So our volume of the cylinder that we're looking for is 12 pi parentheses 100 minus r squared. And that's the volume of the cylinder in problem number 1. And that's our answer, which would be A. Because in a multiple choice, they don't really give you everything and everything. Next up, we'll do problem number 2. I'm sorry, we just did a demo problem, but now this is really problem number 1. Or so you can keep that demo problem in there, which is good. So in problem number 1, it says the diagram shows 2 circles with the same center. The larger circle has a radius of 14 feet and the smaller circle has a radius of r. Our goal is to find the area of that donut. So it's one circle. This is a little radius of r. And the big radius is 14. We have to know the area of a circle. The formula for that, which is area equals pi times r squared. So we're going to do big minus little to find us that little donut. So the area of the big guy is pi times radius squared, so 14 squared. 14 times 14 gets us 196. So the area of the big guy is 196 pi. Then the area of the smaller guy is pi times r squared, because our radius is really just r. So big minus little, it'd be 196 pi minus pi r squared, and that's the area of our donut. We want to factor out. We could factor out a pi. So area equals pi parentheses 196 minus r squared. And that's the formula to get A all by itself, to find that area. That's the function of the area, A. Next up, we're going to do the triangles in problem number 2. So next up here in problem number 2, we're going to find the area of the triangular donut, which is what I just squiggled in there. And our area formula for finding the area of a triangle is half base times height. So now, the small little triangle has a base of b. The bigger triangle has a base of 8 feet. And they both have the same center inside this triangle. So, to find that area of the donut, we're still doing big minus little. So the area of the big is half the base, which is 8, times the height, which wasn't given to us. So we just have to leave it as h. That's all we could do. And then the area of the little is half the base times the height. Now half of 8 you know is 4, so we're going to simplify that one. So the big area of the big is 4 times the h. Area of the small is half base times height. So, to create our formula, big minus the little, because we do the big triangle minus that little triangle, we'll get us what's left over is the little outside pieces. So area of the big guy minus the little guy is 4h minus half times b times h. So what we're going to do, we're going to factor out the h. So you have 4 minus a half b. That's going to be our area formula. Because we can't combine any more like terms, we can't make things even more simpler. Because the half has a variable b attached to it. That's why we can't subtract 4 minus a half b. We can't make that any smaller. And that's our answer. Next up, we'll do problem number 3. Alright, here's problem number 3. We're going to try to find the area here of the rectangle here. So we're going to do big rectangle minus little rectangle. Now the area of a rectangle you can just know is length times width. So the area of the big is 6 times 11, which is, 66. And then the area of the small is 3 times b. So area of the small is 3 times b. So that's 3b. So big minus little. So the area of this donut that we want to find here is 66 minus 3b. Now 66 and 3, they're both have a greatest common factor of those two numbers is 3. So we're going to factor out a 3. We're going to get 22 minus b. When we practice our factoring here. So a equals 3 times 22 minus b. And that's the answer to number 3. Alrighty here. Problem number 4 coming up here, which is a spear inside of a spear. This is kind of like a tennis ball, where a tennis ball isn't really filled with all material on the inside. It really just has an outside layer. So that's what's going on here in the picture with number 4 here. We have a spear inside of a spear. Spear inside of a spear. Our goal is to find the volume of that outer layer, like the tennis ball there. So the volume or the material of the tennis ball. So now the volume formula for a spear is 4/3 pi times radius to the third. That's the volume of a spear. 4/3 pi times radius to the third power. We're still going to do big minus small. I'll find that outer layer. So we're doing big minus little still. To find that outer layer, or the skin of the ball, tennis ball. So this is how we're going to do it here. The volume of the big. We know that the volume of the big, the radius for the big one, is 7 feet, as it says in our worksheet here. So we're going to put 7 in. So big, maybe 4/3 pi 7 to the third power. Now 7 to the third power is a nice big number of 343. So it'd be 343 times 4/3 times pi. And when we do 343 times 4/3, we get 457.3 bar notation pi. Now, I like to avoid the bar notation, so we're going to leave it here as the big. 343 times 4/3 times pi. Now we got to do the little one. The small, the volume of the small is really just, the radius of the small is just r. So we still have the same equation for the little because we're not given the radius. We're just told it's r. So it's 4/3 pi r to the third is the small guy. So when we put this together here, it will be 343 times 4/3 times pi minus 4/3 pi r to the third. That'll be our formula here to find the volume. Let's factor it out. Well, what do we have in common in both sets of terms? Well, they both have a 4/3 and pi in it. So we factor out the 4/3 pi. 343 minus r to the third. And that's our volume. We get the skin of that tennis ball. V equals 4/3 pi times 343 minus r to the third. That'll be answer D on our worksheet here in problem number 4. Next up, we'll talk about problem number 5. Now, in problem number 5, we have lots of information going on here. We have a trapezoid inside of a trapezoid, and our goal is to find that area between the two trapezoids there. And we're given lots of numbers to describe different things. One thing that you need to know is that the area, the formula for area of a trapezoid is 1/2 base 1 plus base 2 times the height. We're still going to do big minus little to find that outer layer. So big minus little is to find that outer layer. So let's plug in the numbers here into the formula, the big formula. A equals 1/2. Our base 1 of the big guy is 15. Plus our base 2 of the big guy is 12. Times our h, our height for the big guy is 8. So what we do, let's clean it up. It'll be 1/2. 15 plus 12 is 27 times 8. Then 8 times 27 or better yet, let's do half of 8, which gets us 4. So it'll be 4 times 27. If I'm following along with my notes, 4 times 27 gets you 108. So the area of the big guy is 108 square feet. Then we gotta find the area of the little guy, which is 1/2 b plus 8, and the height is 5, so times 5. So let's see if we can multiply that out. Well, 1/2 and 5, that's really 2.5, so area equals 2.5 times b plus 8. And that's all really we could really do and simplify and make pretty on with the small guy. We could distribute the 2.5 to both, but then we also get more decimals, and we want to avoid decimals. Actually, let's multiply it out, because 2.5 times 8, you don't really get a decimal. So, A equals 2.5, B, 2.5 times 8 gets you, well, 8 times 2 is 16. 16 times 8 times 1/2 gets you 4. 16 plus 4 gets you 20. So A equals 2.5B plus 20. That actually works out nice. So, big minus little. So we got 108 minus 2.5B. Now, it's a minus 2.5B plus 20, that entire thing. So we distribute that negative, so you get 108 minus 2.5B minus 20. 108 minus 20 gets you 88. So our final answer, I'll put it over here, is negative 2.5B plus 88. And that's the volume of that trapezoid there. The area of the trapezoid. Without defining the area of the trapezoid. With donut area. As far as your multiple choice, it'll be B, 88 minus 2.5B. Because you always really want to leave with a positive. So you have 88 minus 2.5B. That's the area of all that. Next up, we'll do number 6 together, because it involves some radicals. That makes things a little bit tougher. So in problem number 6, we have a hexagon inside of a hexagon. The area formula for a hexagon is A equals 3 radical 3 over 2 times A squared. Now this is a challenging formula to work with, but we're going to do it together. We're going to find that area of the hexagon donut there.